Video we are going to look at section 1.14, which in the current edition of the book that I have starts on page 78. Actually, yeah, 78. So here I say page 79, that's where this label is that we're going to look at. And what we're going to do in this lesson is we're going to use nutrition labels as a way to work with percents, and it's another part of math literacy, learning how to read nutrition labels. So it didn't used to always be this way, but now, included with every food item in the United States, we have a nutrition label. It wasn't that long ago where they weren't on there. So the first thing it says is to find a nutrition label on a product and cut it out and talk about it. We're just going to go ahead and use the nutrition label on page 79, which is for one of my favorites, Junior Mints. So this is on page 79, and it's for a package of Junior Mints. Now I'm on top of page 79, question number 2. Consider the total fat content in your product. Really what we're doing here is we're just looking at the label and seeing what kind of information we have here. So we've got serving size is 40 grams. The total calories is 170. Calories from fat is 30. We have 3 grams of total fat, and then this tells us the percent of the daily value based on a 2,000 calorie diet. Now it's kind of hard to see right here on this PowerPoint, but you might look in your book. It's actually kind of hard to see there as well. Maybe I'll blow that up. Hold on just a second here. Okay, I took this little part of the label here and blew it up. It's a little fuzzy, but at least we can kind of see what's happening here. So these percents over here are based on a 2,000 calorie diet. Now I don't know if you've ever counted your calories before, but 2,000 calories can go pretty fast. So you would have to modify this if you were on a higher calorie diet like 2,500 calories. These are the recommended number of grams for all these things based on how many calories that you're intaking. Another interesting little fact is this calories per gram. Every gram of fat has 9 calories. Grams of carbohydrates, including sugars as well as complex carbohydrates, the calories are 4 calories, and every gram of protein has 4 calories in it. All right, so with our label right here, the total fat in grams for the box of Junior Mints is right here. The total fat in grams is 3 grams. The percent of the daily value is 5%. So what that's saying is if I eat this box of Junior Mints and I'm on a 2,000 calorie diet, that's going to take up 5% of my daily fat that I'm supposed to have. So the calories from fat is actually right here, 30, but this is where it gets in kind of interesting with rounding. Here it tells me that each gram of fat is 9 calories. So if there's 3 grams of fat, 3 grams of fat times 9 calories is going to be 27 calories. So they have 30 on the label, which must mean this 3 grams of fat was more like 3 point something. Like this is rounding up and this is rounding down. There's some funky rounding that goes on nutrition labels, and we're going to see that in an example coming up. Let's look at, on page 79, there's an Explore section, and they start numbering again, number 1, 2, 3. And we're going to continue looking at this Junior Mints label. What percent of the calories in Junior Mints is from fat? Now this is not explicitly on the label. We have to figure it out. So what percent is from fat? So in order to figure that out, we have to take the part of the calories that are from fat and divide that by the total calories, or the whole. One little thing you can use for percents, take this or leave this. When you're working with percents, this little triangle can help you. It's a little formula. You go put the part, the whole, and the percent, and then a little times here, and this is basically acting like a divide. So if you have the part and the whole, you divide those to find the percent. If you have the whole and the percent, you multiply those to find the part. If you have the part and the percent, the part divided by the percent equals the whole. So in this case, we're trying to find the percent. That's what we want to know. So to find the percent, then we're going to do the part divided by the whole. the part of the calories that are from fat is 30 out of 170 total calories. So now we'll use our calculator, and if I punch in 30 divided by 170, I get a crazy number here. I'm out of space. I'll write it over here. 0.17647, and it goes on. This is a decimal, and so to change it to a percent, I move the decimal 2 places to the right, and I'll just round to the nearest tenth. So 17.6 would be the number of the percent of the calories from fat in Junior Mints. You might think it's more, but this Junior Mints are more sugary. There's a lot of sugar in the Junior Mints, not quite as much fat. This package of Junior Mints will account for 5% of a person's daily intake of fat for a 2,000 calorie diet. Where does this 5% come from? Where are they coming up with this? Well, to come up with this answer, we have to look at this part right here that's kind of small. Let me pull in that larger image that we have. All right, so this is that bottom part blown up a little bit. According to this label, a person that's on a 2,000 calorie diet is supposed to have 65 grams of fat. And Junior Mints have 3 grams of fat. So 3 grams of fat out of a total you're supposed to have for your day of 65 grams. If you take 3 divided by 65, you get 0.0461 something something. So if I move the decimal 2 places and then take this 6, which will round that 4 up, I get 5%. So it's approximately 5%. So down here is what you're supposed to be getting for the day, and up here is what the Junior Mints are providing. What percentage of a person's daily allowance of carbohydrates will be consumed if they eat this package of Junior Mints? Show 2 ways to find the answer. Assume a 2,000 calorie diet. Well, it's kind of like the last problem we did. Let's see, we're looking for, what are we looking for? What percent of a person's daily allowance of carbohydrates? You see that in here anywhere? How about right over here? So here's carbohydrates, here's the percent of daily values. So one way is it's to read the label. If we read the label, we see that it's 12%. Another way is we could actually figure it out. So to figure out the percent, again, we need to do the part divided by the whole. So what is the part of the carbohydrates of the day that come from this package? So this package is providing 35 carbohydrates out of, what's the whole number of carbohydrates a person with the 2,000 calorie diet is supposed to have? Well, we got to refer to this down here. Let's find the carbohydrates. Looks like 300. So they're getting 35 grams of their carbohydrates out of their 300 for the day. So if I punch into my calculator 35 divided by 300, my calculator says 116 and then a whole bunch of sixes. Is that 12%? It's supposed to be 12%. Well, move the decimal 2 places. This 6 is going to round that up to a 2. So if I round to the nearest percent, I'll have 12%. So that's 2 different ways that we could get that answer. Find the number of calories per piece. Number of calories per piece if there are 16 pieces in a serving. Why don't you pause the video and see if you can get that one. The key word here, if you're not really sure where to start, is per. Actually, this whole phrase is very helpful. Calories per piece. Calories per piece. Whenever you see that, it's calories per means divided by the pieces. So the number of calories is 170, and the number of pieces they told us was 16. I kind of like writing it as a fraction because when I write it as a fraction, I get the unit of measure right here, calories per piece. So I punch into my calculator 170 divided by 16, and I get 10.625, we could round that probably, calories per piece, or approximately 11 calories per piece. There, all you gotta do is just have one piece, and then 11 calories, no big deal. That's tough. So I talked to you about misleading labels. This is one of my favorites. If you have some kind of spray, olive oil spray, go check out the label and see if you have something like this. 0 calories. Okay, so first of all, I want you to notice the ingredients. I found this on the internet because somebody's worried about the propellant, which sounds a little dangerous to have in there, but that's not our topic. Our topic is the ingredients. One of the ingredients here is canola oil. Okay, canola oil is a pure fat. So as we learned, that's got 9 calories per gram. There's definitely calories in canola oil. And yet the label says amount per serving 0 calories. No fat. How can they say that? Well, check this out. Serving size. The serving size is 1/4 second of a spray. Okay? We're going to spray this for 1/4 of a second. And however much oil comes out, they're saying that's 0 calories. So basically, there's some calories, right? So let's say you spray it for 1/4 of a second and a little glob comes out, and that has, because it's so tiny, it has 0.4 calories. So where does that round? Well, that rounds down to 0, to the nearest whole number, and then they put 0 calories on the label. Terrible. There's not 0 calories in here. All right, I would call that misleading, and anybody that can spray this for 1/4 second is pretty impressive. Now I found this label, which at least has a little bit of integrity to it, although their serving size is even smaller, 1/5 of a second spray. That's even less time, and that's why they're claiming this big 0 calories. But a little bit of integrity down here. If you spray it for a 1/2 second, if you go crazy and spray it for a 1/2 second, you'll get 1 gram of fat and 9 calories. Now, if you're super nuts and you're just letting it all go and you spray for a whole second, you'll get 2 grams of fat and 18 calories, which is much more realistic. Kind of interesting. Another thing that was kind of interesting to me is comparing foods. I was actually, I have both of these items in my house, and I like to eat this ice cream at night, and I like to eat sometimes this for a snack in the midday, or sometimes for breakfast if I'm going too fast, if I don't have time. And I got this, I had my wife grab this, and I grabbed this, and I said, let's compare these things. So this is supposed to be some fancier, ice cream. And the whole thing, it's not very big. It's kind of like one of those you can just hold in your hand size. This isn't very big. So the serving size is a 1/2 cup, and there's 4 servings per container. All right, so, but I usually eat the whole container. So calories per serving is 80, but there's 4 servings in there. So the total calories is 320. Okay, and over here, what's the calories of this fancy protein bar? 280. Pretty close. This got more calories. Okay, let's look at the next thing, fat. All right, so this has 2.5 grams of fat, but remember there's 4 servings, so I multiply by 4. So that's going to be 10 grams of fat. Let's look over here at this bar. 10 grams of fat. Okay, same. Saturated fat, that's supposed to be the fat that's bad for you. 1.5, multiply that by 4. So the saturated fat is 6. Saturated fat over here, 5. That's pretty close. Let's look at protein. Okay, protein, 5 grams right here, times by 4 servings. That's 20 grams of protein in this little pint, I think is what it is. That's not bad. What's the protein over here? 20 grams. Wow. These are actually kind of close to each other. Now let's check out sugar. Where's the sugar? This has this weird thing called sugar alcohol. I don't know dietarily how good or bad that is for you, but sugars It's got 24 grams for the whole thing, and this guy's got 22. So you know what? These two items of food, as far as I can tell, and we didn't look at every single thing. I think the sodium on one of these is a little bit higher. I think the sodium on this might be higher than this one if salt's a thing. Actually, no, they're pretty close again, aren't they? This is 110 times 4, that's 440, that's 360. This has a little more sodium. I would never eat this ice cream for breakfast, but I would definitely eat this for breakfast. And yet, nutritionally, they're very, very close nutritionally. I guess one thing that this protein bar, and you guys can't see this, but there's all this like vitamins and mineral stuff down here that they add to it that you could get by taking a multivitamin. But, you know, looking at nutrition labels can be very, very enlightening at times. So I encourage you to do that when you think about what you're eating, and if you're really interested in what you're eating, that nutrition label is full of fantastic information. All right, back to our junior mints. We have a couple more questions about our junior mints. So far, we've just looked at people with a 2,000 calorie diet, but what if someone's on a 2,500 calorie diet? What percentage of the daily allowance of carbohydrates will be used if they eat a package of junior mints? So we're looking at the carbohydrates. So if we look at our label, our total carbohydrates is 35. And for someone in a 2,500 calorie diet, actually let me go to another slide where the numbers are bigger. The total carbohydrates for someone with a 2,500 calorie diet, they're supposed to have 375 carbohydrates for the day. And the junior mints have 35. Okay? So the junior mints are providing 35 grams of carbs out of, that's the part, out of the total recommended for someone with a 2,500 calorie diet is 375 grams of carbs. So if we divide that, we get 35 divided by 375 is 0.09333. Let's round this to the nearest percent. So that's going to be approximately 9%. As compared to someone that's only on a 2,000 calorie diet, their percent of carbs for the day is 12% if you're on a 2,000 calorie diet. If you're on a 2,500 calorie diet, then this is only going to make up for 9% of your total carbs for the day because you're going to eat more calories. How many calories are there per gram of junior mints? Do you see the key word there? Calories per gram. Calories per gram. Why don't you pause the video and try that one? All right, so if you remember, our per means divide. So the number of calories from the label was 170 divided by the number of grams in the whole package. I don't think we've talked about that yet, but it's right here. The serving size is 40 grams. So we have 170 calories out of 40 grams. So if I punch that into my calculator, 170 divided by 40, I get 4.25 calories per gram. Number 7, the label says there are 30 calories from fat. How is that number calculated and how accurate is it? Well, we actually kind of talked about that earlier when we said that the label is showing, where is it? The fat was 3 grams of fat, and each 3 grams of fat, and each gram has 9 calories. 9 calories per gram for fat. So if we multiply that, we come up with 27 calories. So that's where it's supposed to come from, and it's not quite accurate. All right, it's off by a little bit. All right, we're going to look at this bottom part of the label a little more closely. And question number 8 says, create a rate comparing suggested saturated fat grams to total calories for a 2,000 calorie diet and simplify the fraction. Rate is basically like a ratio with unlike units. So we're going to be dividing two numbers to find a rate, and the units are going to be different. So in this case, we're comparing the grams of saturated fat, so that's going to go on the top, 2, and the 2 is where your divide sign is. You know, when you're doing ratios, there's a 2 there. That's what this divide sign is for. The total calories, so that number is going to go on the bottom. Saturated fat grams to total calories. Okay, so the saturated fat grams for a 2,000 calorie diet is 20 grams. So that's going to go on the top. 2 total calories, which is 2,000 calories. So now we need to reduce this fraction, and we can see that these zeros are going to basically cancel because they're a multiple of 10. So we'll have 2 over 200, which will reduce down to 1 over 100. And that would be grams per calorie. Now, one way to think of this is 1/100th of a gram per calorie. That's kind of hard to think about. If we keep these separated like this, and then remember that this means per, what this is really saying is you should have 1 gram per every 100 calories. And remember, we're talking about grams of saturated fat. So you should have 1 gram of saturated fat per every 100 calories that you're consuming. And that would be the rate. So similarly on 9, we're going to create a rate comparing suggested saturated fat grams to total calories for a 2,500 calorie diet. So here they're suggesting 25 grams of saturated fat to every 2,500 calories. Okay, so if we reduce this down, 25 goes into 2,500 100 times, or we could divide the top and bottom by 25, and look what we're going to get. We're going to get the same thing. 1 gram of saturated fat per every 100 calories. Those should come out to be the same. All right, if I'm on a 2,000 calorie diet, I get less grams of saturated fat. If I'm on a 2,500 calorie diet, I get 25 grams of saturated fat. But these are what we call proportional, all right? They're like fair or equal. For every 100 calories, you get 1 gram of fat. So that's what we noticed. For 8 and 9, they came out the same. Interpret the new simplified rate in words. Well, we kind of already did that on the other page, but we could say for every, we'll turn it around just a little bit. For every 100 calories consumed, what am I going to say next? It is recommended, well, you probably didn't think I was going to say that, but it is recommended that 1 gram of saturated fat is consumed. All right, so again, what we're talking about here is proportion, proportional. When two rates are equal, we say that they are proportional to each other, that it's fair. So in this example, we have the rate of 1 man for every 5 women, and we have a different rate of 3 men for every 15 women. That is proportional. These are proportional to each other. Let me give you another example. Let's say you're comparing teacher to student ratio. That's kind of like a big thing in schools. So if you've got one school that has 100 students and 5 teachers, say for a certain grade or something. Then this rate, 100 divided by 5 is 20. So we have 20 students per teacher. Now let's say I've got a bigger school, and in that school there's 500 students in a particular grade, but there are 25 teachers. So if I divide 500 by 25, I get 20 students per teacher. So even though this school has way more teachers, it's also got way more students. So we would compare these rates, and if they're the same, then we would say that the student to teacher ratios here are proportional to each other. They're fair, right? They're the same rate. So we can check proportionality using decimals as well. And they want us to convert the fractions from number 8 and 9 into decimals. So let's go back to 8 and 9 and see what we got. All right, so 8 and 9, we got 1 over 100 grams per calorie for 8, and we got the same here. 1 over 100 grams per calorie. And we looked at that at two different ways. We also looked at it as 1 gram per 100 calories. But we could also look at it as a fraction. So punch in 1 divided by 100. Some of you should already know what this is and not have to punch it in, but we'll double check that. So we could also say you get 0.01 grams per calories. You can use decimals as well to compare these values. So for this problem, we're going to use the fact that we have from before, which is for every 100 calories consumed, that we expect to consume 1 gram of saturated fat. Okay, so when saturated fat grams go up by 5, diet calories go up by how much? Use this fact right here. Well, hopefully you're getting, if you've got 5 grams and every gram is going to account for 100 calories, this is going to be 500 calories. Multiply this by 5, then you have to multiply this by 5. That is the essence of being proportional. So if saturated fat grams go up by 1, diet calories go up by 100. When one increases, the other does as well, at a specific rate of 5 grams of saturated fat for every 500 total calories, which is the same as 1 gram of saturated fat for every 100 calories. Since it's suggested that this particular relationship being maintained regardless of the number of calories in a diet, let's determine how many grams of saturated fat we would be allowed in one day if we had 3,000 calories. I remember learning about Michael Phelps when he was swimming. He ate like, oh gosh, the number 25,000 is popping in my head. I'd have to go look it up because it sounds ridiculous, but it was some ridiculous amount of calories. In other words, complete this proportion. All right, so 20 grams of fat per 2,000 calories would be equal to how many grams of fat to 3,000 calories? So we haven't really discussed how to solve proportions like this, so we're going to use scaling in order to figure it out. If you know how to solve this because you've had some kind of algebra class, go ahead and solve it how you know how to do it. But we're going to use something called scaling. So the idea here is you're just going to change the fraction by multiplying or dividing the top and the bottom. So we know that we get 20 grams of saturated fat for 2,000 total calories. So we're going to scale that down to this rate. What you do is you look at these numbers here. What would I have to do to get from 2,000 to 500? What would I have to divide by? It's always dividing and multiplying when you're dealing with proportions like this. So I would have to divide this by 4 to get to that. So in order to fill in this top number, I also have to divide by 4. So 20 divided by 4 is 5. And if you don't like scaling that far, you could scale a little bit differently. You could divide by 10. So that would get you to 2 grams for every 200 calories. We're trying to get to 500, so maybe I'll divide by 2. Well, that takes us back to where we were before. 1 gram of saturated fat for every 100 calories. And then I could multiply by 5. Multiply or divide. What I mean there is you have to multiply or divide. Don't go adding stuff. So that gives me 5 grams for 500 calories. This is the idea of scaling up or scaling down. But what I want to do is I want to scale up to 3,000. That's what we're trying to find. 3,000 calories. So what am I going to have to multiply 500 by to get, oops, left to 0, 3,000? Hopefully you're saying 6, right? We got 2 zeros at the end, 2 zeros at the end. So basically 5 times what is 30? That's 6. So I have to multiply the top by 6, and that's going to give me 30 grams. So that's the idea of scaling. Okay, so back to this question. This answer right here is 30 grams. And there's other ways to do it. If you're looking at this thinking, hey, I know a different way and I got 30, great. Do it that way. All right, last question. Estimate the suggested number of milligrams of sodium for a 3,000 calorie diet using the information from a 2,000 calorie diet. Is the suggested number of milligrams of sodium proportional to the number of total calories? Well, we need to go look at our label, so let me go get it. So let's answer the first question about the sodium. Estimate the suggested number of milligrams of sodium for 3,000 calorie diet. All right, so down here for sodium, it's kind of tiny. Hopefully you can see it in your book. Sodium for a 2,000 calorie diet, we're supposed to be at 2,400 milligrams for a 2,000 calorie diet. So what we want to do is try to figure out how many milligrams would that be for a 3,000 calorie diet. So I'm going to use the scaling again. These are all in thousands, so I'm kind of inclined to get this down to 1,000 on the bottom instead of 2,000 calories. If I divide this top and bottom by 2, that's going to give me 1,200 milligrams of sodium for every 1,000 calories. So now if I want to scale up to 3,000, I can just multiply by 3. And that's going to tell me 3,600 milligrams of sodium for every 3,000 calories. So the estimated suggested number of milligrams of sodium is 3,600 milligrams of sodium if you're on a 3,000 calorie diet. Is the suggested number of milligrams of sodium proportional to the number of total calories? Well, in this case, the answer would be yes. That's what scaling does for you. If you're scaling, you're going to remain proportional. If you're scaling, okay? Now, one last thing that I kind of noticed here, maybe you noticed, but I don't know that I agree with. I'd have to do a little more research on my nutrition. Looking at this label right here for a 2,000 calorie diet or a 2,500 calorie diet, this amount of sodium is staying the same. Notice the sodium here didn't change, 2,400, 2,400. I know that might be a little hard to see, but that's what it says on that label right there. It says on that label 2,400 milligrams of sodium for a 2,000 calorie diet and 2,400 milligrams of sodium for a 2,500 calorie diet. So what they're suggesting there is that the amount of sodium is going to be constant for everybody. Now, if that's the case, if you want to look at it that way, then you may have answered, well, then I guess I get 2,400 milligrams of sodium for a 3,000 calorie diet. Now, if you do it this way, then the answer to the last question, is the suggested number of milligrams of sodium proportional to the number of calories? If we do it this way, then no, it's not proportional. If you divide these fractions, you're going to get different numbers, and that means it's not proportional. If you divide 3,600 by 3,000, let's do that. 3,600 by 3,000, I get 1.2, so that would be milligrams of sodium per calorie. Now I'll come over here and I'll divide 2,400 by 2,000. 2,400 divided by 2,000, look at that, 1.2 milligrams per calorie. That is what proportional means. This down here, if you divide these and keep the top number the same and change the bottom number, those are not going to be proportional. All right, so I know this was a big lesson and there was a lot to do here. A lot of important concepts. We've got our math literacy, being able to read labels, work with percents, find the percent. We also talked about proportions. We talked about ratios. We talked about rates. Determining whether things are proportional. A lot going on in this lesson. It might be worth going back and starting at the beginning and reading through what we did here to really understand proportions. They are a very important part of mathematics and life and cooking and baking and mixing and putting oil and gas in your not your mower, but like some things require oil and gas mixed in their tank, like a weed eater, little 2-cycle engines and stuff like that. It's just very important. My wife works for this city, and she has to mix weed killer to water, and it has to be, if you have a bigger size tank, you got to make the weed killer proportional to the water. So we'll be dealing with proportions quite a bit throughout this course.